All right. So this call, the one that we are having now, any of the transaction in the world you are seeing, any scroll on social media, whatever comes to your mind that goes online or happening online, it goes through a data center. So let's just think about it this way. And I will not talk about IT knowledge. I will not talk about the IT infrastructure. I will not talk about what is inside the servers, how this network is built. I'll just try to make the wider knowledge and a wider picture of it. So, first, everything is happening online in our life that's happening during a data center. Now, what is the data center? Just think about these pieces. It is servers. So, anyone who works in any room, inside your house, if you have a small router, consider that a small data center. So anything that depends on the size, I will not explain the sizes here, but server, then these servers inside it have some place to store, mainly for the cloud data center. Then networking, fiber in, fiber out, internet connection, wireless connection, then power and cooling, because these infrastructures require power to run it, require cooling to cool it down because it's heating and produce a lot of heat. Now, I'll give you just one number. The global market in 2020 26, there is a $430 billion, the amount of the investment in the data center. So maybe many of you, including me before, we don't know what is data center, but it's a really big industry running in the world right now. Now, why does it matter? Why the data centers matter for our life? Whether we are engineers, not engineers, anyone in life, why the data center is important, especially nowadays with the online and digital transformation for everyone. Any media, as I told you, this call now, it's hosted on a data center. Any media, any YouTube video, any TikTok scroll you see, it's on a data center. Banking, payment, online payment, anything you do now, you go to your Netflix, you recharge your account, that's happening on a data center. Netflix itself. So let's take this example. You are watching on Netflix. So the host service of Netflix is on a data center. When you create your account, that's on a data center. When you make a bank account transaction to activate your account, it's from your card, Visa or MasterCard, that they have their own data center. Through your bank, wherever you are, that's on a data center. It's going to a company that hosts this transaction, like Stripe or other companies. They should have like a storage on data center. Then Netflix itself, they have a data center. So you can imagine how many of the services involved in one single transaction happening in your life. A cloud and AI. So what's the cloud? What's AI? Simply cloud is the storage. If you are an iPhone user, you have iCloud or Samsung Cloud or whatever, Huawei Cloud, Google Drive. So that's used as only storage. You store something inside. When you need it, you take it out. So it's just a storage, not on your PC, your local PC, not on your phone. It's stored somewhere. That is the cloud type of data center. The other type of data center is the AI. AI, now, when you have your ChatGPT, Cloud, Gemini, whatever you are using, when you are processing some information, this information stored on a servers on something called AI data center. The people who continue and will take the class with us, we will go deeply inside those because I don't want to run out of time here to explain everything. So AI is when you have a process of information. The cloud is just a store. You have an information, you have a picture, you store it in the cloud. When you need it after 1 year, 2 year, 1 month, you call it, it comes to you again. That is the cloud, just a storage. AI is a processing of information. So example, I won't take like very deep technical example. When you do like any question to your ChatGPT, Gemini, or whatever, that process of thinking, it's happening on a data center. The AI is now the future of the data center, and it requires a huge capacity, a huge power, a huge infrastructure. That's why the data center now is booming in uncontrollable way. Data center is not new. It started long time ago. The current type of data center is also not new. But with the AI, past 2 3 years, things gone crazy with the data center. Communication, all the networking companies do Etisalat, STC, AT&T, wherever you are, Orange, Vodafone, they are hosting their services on data center. The calls that you are doing, the mobile call, the SMS, it's on a data center. So now I just want you to imagine what is the capacity, what is the size of this business. It's not something that just coming. Maybe we were outside it. We don't know what's going on. But anything you do in your life, it's happening on a data center. So you can imagine what is the demand, what is the capacity needed with the AI, with the digital transformation, what is the future here. Now, we have few types of data centers. We have I will start from the enterprise. Enterprise data center is the enterprise itself, they have their own data center. Like I'm a financial company. I need my data to be stored within my control, my territory, my infrastructure. So I can make my enterprise data center. And it will be very small. It will be in the size of a port cabin. So the people in the site, they know what is the port cabin, the site offices. It is almost in that size. It's in the size of like a small room, just the servers for the enterprise itself. So as I told you, I'm a financial company. This is my data center, nothing else. There is the edge data center. What is the edge data center? From the name, you can understand it's on the edge. Means so the enterprise is private, only for me. Edge is low latency. That is some kind of technical and more into network knowledge. Means it's near to me. It's always near to me. So, for example, the telecommunication companies, they use the edge data center. Why? Because they need every coverage area. The people there use their data center for low latency. Low latency means in a very simple way, like very high speed. So I need a high speed for SMS. I need a high speed for the calls. I need a high speed for response. So I have small data centers around the world. We have kind of data center that called co-location. Co-location, think about it like a rental. Like a rental. So I build the data center. I'm a developer. I build the data center. Then I start renting spaces inside my data center. So I run the security. I do the design. I do the construction. I do the operation, the management, everything. Just like a tower. When you have a tower, you lease a unit for 1 year, 2 years, 3 years, whatever. And you need 1 bedroom, 2 bedroom, 3 bedroom, 4 units, 5 units, 1 unit. So that is the co-location. It's a shared services. You will have your own private space inside the data center, but you are sharing the power utility, you're sharing the cloud, the security, the cameras, everything with the other. And it's under the control of the developer. We have the new one is the sovereign data center. This is kind of national data center, and it's mostly by the governments. Like now UAE, KSA, they are they're already building these data center to store the national data on these data center. Rather than I go to Microsoft and I use their services, I build my own data center. So I build it inside. I put all my government information, all my government processes inside it. And this is now the trend in the countries. They build the government build their own data centers to store their government services, archives, operation, in our data center. So it's kind of government data center. Now, we have the hyperscale. Hyperscale, these are very big data centers. So all of the other that we spoke about varies in the size. As I told you, for example, the enterprise, it would be very small. It would be 1 megawatt, 2 megawatts, 5 megawatts, very small. The hyperscale, it's big data centers, huge data centers having the capacity of 100 megawatt plus. Don't be panic. I don't know, like some of you might be asking what is the megawatt. We will talk about it. So these in the size, if you can imagine the size of them, it's in the size of a football stadium. So the full campus with the infrastructure, it's roughly in the size of a football stadium. So that's size you can imagine. Don't think about data center as just a small rack in the room or room inside the building. We are talking about the new type of the hyperscaler of the AI, big campuses, and even bigger than. I'm just giving you like an average example, just for you to imagine. It's a football stadium size. Those are usually run by a hyperscale, like hyperscale operators. Who are they? Microsoft, Google, Amazon Web Services, AWS. Uh, like for example, now in some places we have Alibaba. They are also entering this business. We have, like I said, Google, Microsoft. We have Equinix, Oracle. These people. Equinix is collocator. They are building. These people usually they don't build their data center themselves. They ask other developer to build for them, but they rent it fully. They don't accept the share. That's the difference between colocation and hyperscale. Hyperscale, you build and you rent parts of it. Hyperscale, you build as a developer, but the hyperscaler will take the full campus. They don't accept because they have their own security, they have their own specification, rack, densities, their own specification. So even before you start building, you should contact them to see who is interested, who will sign LOI with you, like letter of interest or LOA or inter-lease agreement to build based on their requirement. I have a project, it was for Microsoft. When we shift to Google, Microsoft did not like it and did not continue. We have to change the full project because Google specs is different from Microsoft specs. So this is like in a brief, what are the different type of data centers? So what is the project phases? When I say project phases, I don't talk about contracted work only. I don't talk about the construction. I know some of you coming from contractor background. I am not talking about the contractor here. I'm talking about the project lifecycle. So the first thing, it's called feasibility and site selection. What does that mean? I am a developer. I am building data centers. So I need to expand in Uganda, for example, or Finland, or wherever. So first, I need to go there, make a feasibility study. This feasibility include many. The people will be with me and our the people with me in our course. We will go for this in more details. But majorly, I look the type, the plot, the prices. But this is just the commercial. Mainly, it is the technical, the power, the fiber, the water availability, the resources availability, the security. Is it a war zone? It is a stable area. It is a commercial area. We have to study all of these, pull them all together in something called a business case before I enter into agreement to lease that plot or purchase it. Now, I have done that, and we have do that a lot. We have I myself, I was part of around 20 or 30 unsuccessful site selections. We spent months and months and months, then we decided no, we will not continue through this site, we will not continue through this site. Even we build million, but you build million and you lose them in the beginning rather than selecting a site that will cost you hundreds of millions. Now you selected the site, you continue everything, you start the design and engineering. Here I put only design and engineering, but it's included the authority because authority here is the main bottleneck for all of the data centers. You start designing your data center and you design based on the capacity. And this is the megawatt in the previous slide we spoke about. The data center is calculated by megawatt capacity, megawatt IT. So how many power the rack are consuming. This is defining my capacity. Understand that. So when I talk about, for example, when I speak in real estate, we say the GFA or sellable area or built up area. Here we measure it by the megawatt capacity, IT megawatt. So this is the first thing you should know, what we are building, because it's not easy at all to change it later. No way. You can build it in phases. You can say that I will design 100 megawatt, but currently I need only 20 megawatt. So I can design the full campus of 100 megawatt, then I go for the 20 itself. This is not the case, and the other way around. I cannot design a 20 megawatt, then I need to shift it later to 100. It can't be. It can, but it's unfeasible. During this stage of design and engineering, we should go for environmental impact assessment. This is very important in the data center, especially in Europe and mainly in Europe. Mainly in Europe, it's very difficult. It's long time. It takes you from 12 months and further even securing the power agreement during the design engineering, and that should be studied in the feasibility stage. I should have a power. I should have agreement on the power. I should know there is a power. Otherwise, a data center without a power, it's nothing. It's just a building, just a big commercial building. Now, design and engineering, it's in the stages. We will take it in details in the course. The procurement is very important. Here, securing LLE, long, you will hear a lot, LLE, long lead equipment. This is a major driver for the project success and completion. The procurement of these items, usually generators, the very important ones, chillers, crack and the CRADs for the like CRAH, CRAC. These are a mechanical equipment for cooling, UPS, uninterrupted power supply, but because there is a redundancy here and power that always to be running. We will go to this next slide. Then procurement need to be secured. You need to understand that there is a shortage in the supply in the world. And when we talk about generator, usually in your buildings, you have one generator. Maybe it's maximum 2 megawatt capacity. You can get it from anywhere. And there is no specs for it, like in the real estate, if you are at a tower or something. Maybe in the hospitals, they have some kind of different specification for the generator, but it's not up to the data center specification. Here, the generator is the major and very important part of the equipment. In one data center, if you have 20 megawatt, for example, and this is a very small data center nowadays, you will require around 5 generators. If you are designing tier 3, you would require 4 generators of 2.5 megawatt. These generators together, we said 4 into 225, that's 10 megawatt. Each one is $1 million. So we're talking about $10 million order of generators. That's for a very small building. It is just 20 megawatt. And this could take 12 to 18 months to be delivered. Then after we secure all of these, we start the civil and construction work. Civil and structural work, you need to understand the sequence of data center. You cannot treat it as a normal construction. You should understand what is the civil and structure here, why I should build the gantry of the generator, why I have to finish the interlock at the beginning, why I need to finish this area before that area. That's a full logic. We will study it in the course. Then the MEP installation, and just revise your thinking here. The MEP is the work here. The MEP is the contract. The MEP contractor is the main contractor here. It's not just a subcontractor, because all of the work here is MEP. Then testing and commissioning. Testing and commissioning is the success of the data center, and you cannot just wait until the end of the data center building to think about the testing and commissioning. This is something planned in the design stage here. You plan what you are going to install, what you are going to test, what you are going to commission. And it would take around 3, if we start from level 3, that is the real installation, not installation, that is the real like energization. Level 3 to level 5, that itself, just that itself take 3 to 5 months. And any failure on this could bring a 12-month delay to the project. Then IT fit out and handover. Now after the sixth stage, you as a developer or a main contractor, you hand over the building, but the building is not yet ready. Now it's the part for the end user, the telecommunication company, the banking company, the hyperscaler, Google, Microsoft, or whomever. They will come take. That's called the gray space. What we are building now, it's a gray space. The white space, it's the server rooms. Then they will start install their IT equipment, their networking, their servers, their racks, whatever inside. After that, this now called a data center. When it's ready to host services, this is called a data center. This full life cycle, it could take between 18 to 36 months. Before it was taking more and more. But now, because of the demand, because of the shortage of the supply, because of the understanding of many people of data center, they start enhancing those process. So we reach 18 months, 20 months for a 20 megawatt, up to 50 megawatt amples. Usually it takes more, depends on the country as well. I have a project in Finland. The power agreement with the environmental assessment itself would take 18 months. So you cannot do anything in this 18 months, only the design and the procurement, but you cannot construct. So it will take 36 months by default there. Okay, who work on data center? Like who's involved in data center? Civil and structural engineer, as we spoke in the last slide. MEP engineers, usually. Planning and project control. And the planning and the project control is a very important key persons here. And the real estate and the normal construction, hospitality, hospitals, healthcare, you deal with the project managers, with people who really understand the business. So they help you, you help them. Here, you are a key and like you have a pivotal role in the project because you need to, what I said in the earlier slide, you need during the design time, you need to think about commissioning. During the procurement time, you need to understand what's gonna happen. While we are doing the design and we understand the generator, you should design your program to build your program of civil structure to be finished at this time before that time. It's very important. And guys, I'm telling you, I suffered myself to find the planners when I have team and I wanted to bring people to my team, especially in the Middle East. I couldn't find. I really couldn't find. I hired people from Ireland, UK, the UK, Netherlands, the US, just because they have built one or two data center. And when I say that, don't think it's a rocket science. The people came that they know something no one else is knowing, but because they just saw a data center, they understand the sequence. So planning and project control, they are very important people, very important role in the data center. Commissioning engineer here are a vital, like a vital role. There's companies only for commissioning. There's certificate for commissioning. There is commissioning script, pre-script, and commissioning agencies. It's very important here, a very important role. IT and network team, definitely. It's like an IT utility or IT building. So you need them. DC operations. So after you run that and you go, there's operation. Continuous operation, people who monitor the heat, who monitor the load, monitor the electric, monitor everything inside. So that's called the operation of the data center. And that's continue as long as the data center is up and running. Project managers, program directors, the real estate and investment professional, because the real estate people, real estate investors, they are transitioning into the data center right now. And they have the biggest knowledge because they build things, but they don't understand how to build a data center. So they have the half of the knowledge. Now, big player in the GCC. I think some of people here are mostly from the GCC. In the UAE, 70% of the data center in the UAE is from Khazna data centers. We have the Mag Digital, my previous company, Do and EAN, previous Etisalat. Econix. Econix is the biggest collocator in the world. They have branches everywhere. In Saudi, we have Center 3, which is belong to STC. We have Saudi Aramco and NEOM. We have the global hyperscaler are investing there. And the world, we have Digital Real. Econix is the biggest one, I think, so far for the collocator. Digital Reality, NTT data centers, And per region, each region there is data center players there. You can search it. Take this like as an exercise. Go and search who work in data center in your country. I don't know where are you from, guys. Search who's working there, who is the collocator, who's the operators. Then by default, we have the as I told you, the hyperscalers. Like, now the question: can I transition into data centers? Like I work in real estate, villas, project. Can I? Yes, you can. You have the skills in the construction. It's a construction. We are doing construction here, but you need to understand how to make this transition. What you need to bring from your previous knowledge and what you need to build as a new knowledge. It's not the same. If you just think it's just a building, I will go there, do the building. I know myself, companies, not people, not individual. Companies lost millions and they were so successful in the real estate, in the hospitality, and developing communities in different parts of the world because they just think this is a good chance, new opportunity, new building, let's go and build. They lost millions. So, what is the skills you need to transfer? Construction experience, all of you, I think, have it. MEB knowledge. And when I say knowledge, I don't expect you guys to know technical things like calculating CFD, calculating voltage drop, calculating the busbar size, not that. But you need to understand what is the busbar, what is the chiller, what is the function of the chiller, not what is inside the chiller. What is the function of the chiller when I need to install it? Project control methodologies. You should know the critical path. You should know the sequence, hard logic, soft logic, how you use the floor, how you sequence, how you use like finish start to start, flags, leads, etc. And I think most of you are having it. What you need to know: DC design standards. You need to understand by default when someone tell you tier one, tier two, tier three, redundancy, redundant, N plus one, double N. What does it mean? Not what does it mean because it's a technical term. What does it mean for me as a project manager or as a planning manager? What does it mean? When I say tier three, by default, it's N plus one. So N plus one, that amount of generator plus another generator, then I should have two redundant power supply. So when I do the plan, we sit with the project manager with the people, where is the other power feed? When it's coming? What time it's coming? What is the entry route for it? The fiber, how many fiber we have? Do we have the first one? Do we secure the second one? That is the knowledge you should know. A procurement timeline, here it's different. I work a long time, really long time in the real estate projects. Long lead items, 6 months, 5 months, 4 months. The specs is very low. It comes from China, it comes from Europe, it comes from GCC. No one cares. But here in the data center, you should understand the procurement cycle, the procurement process, the procurement timeline, and what is the capacity you are talking about. 25. If we talk bang about 7 million, 25, yes, almost 25 of the data center, 25% of the data center cost coming from long lead equipment. And 70% of the failure comes from procurement. Commissioning methodology. What is L1, L2, L3, L4? The people who joined me in the past, in the last session, they would know we went through the commissioning. The people who will continue with me from Sunday on the DCPP framework, we will go deeply into the commissioning methodology because it's very important. But you should understand what is L1, L2, what's happening in the factory, what's happening on site, what's happening when I connect power, what's happening when I energize the system. End-to-end DC life cycle, which is the second slide we spoke about, but in details. Because you are a planner, you are not only a contractor planner or contractor project manager. You could be on the developer side, on collocator side, or on a hyperscaler side. You are renting, so you should go to vet and challenge those people. Now, how big is the market? As I told you, the global market, and these numbers based on GLL, you can easily go GLL, CBRE, McKinsey and Company, and all those big consultants, and check the numbers. 430 billion, the global market of the data center, $430 billion. Bilal, can you understand? Can you imagine the $430 billion? I think Bilal on a mute, he's silent. The number is big. Dr. Suraj, give us some example of the 430 billion market. What does it mean? What is the job market here?
Yeah. Sorry, Baran. So actually, I joined you late, so you guys have gone far.
No problem.
So
We'll go but I've just thrown a number. I just have thrown a number of $430 billion all in 2026. So what you can imagine the job market there?
uh you meant the current market in the US, right?
It's globally.
Well, I'm not actually sure about the projection, but I know there is a lot of ongoing hyperscale data center going on especially in the North American side of things. So I think generally this projection, I think it's just from, if I can remember very well from the last projection I saw, I think it's running into trillions of dollars, the market globally
All
now.
right. Yes. Yeah.
Yeah.
Sorry. Sorry. I don't want you to like bring numbers. I just need to people to think with me. Because I feel I'm talking alone. So this means thousands of jobs only in 2026, and the projected $1.1 trillion in 2035 in the upcoming 10 years. So there is around gigas, thousands of megawatt under construction. If I will give you an example of a project of like 20 megawatt, I have a project 20 megawatt in Greece. How many people work there? You have the developer team, you have the consultant team, you have the contractor team. In each of these, you have a director, you have planning manager, you have quantity surveyor, you have planning engineer, like help, like planning manager, planning engineer, you have construction director, you have site engineers, you have electrical, mechanical engineers, design engineers. So you can imagine the size of this market. So what's my advice? If I have an advice and I can bring every engineer in the world and tell him an advice, go to this sector now. Even if you cannot find a job in the next year, 2 years, you cannot find a job, which I doubt, but enter it now. Know it now. Connect with the right people now. This is your chance. You will be a leader after 2, 3 years when the market's booming in 2035. All right. So now I have gone quickly through those slides. I will give you the chance to ask questions, but don't go very technically because as this is just like a major knowledge. Tell me what first on our slides what you need to ask about. I will give